Hello there, welcome to this video where we will be looking at default arguments and function overloading. Alright, so we have some simple notes we can go through and then understand what this concept talks about. So when we talk about default arguments, these are arguments we give to our function. Alright, and with that, we usually give this argument in our function prototypes. Right. So what do we actually mean by default arguments? Let's go into our compiler and write a simple function and see what we mean when we say we have a default argument or we are passing some default argument, right? So let's write a function that has two integers. So let's just say int, let's have int a and int b. Let's still return a plus b, just that's right. And let's do our function prototype. So right here we can do this. Let's copy this and then paste it here. So we can say equal to a is equal to 2 and b is equal to 3. Then we end this with a semicolon. This right here is what we call the default argument, right? And they are usually done inside the function prototype, right? Yes. So if we are to call this function in our main function and we don't specify any values for the function call, these values will be used in place of our expression here, right? So let's just call this function inside our main function. Let's do some, and we are not going to pass anything. All right, so let's pass the result into some variables here, result, and let's assign the value to it. So this is, let's print it out, see out the result. All right, so if we run this, even though we didn't specify any values here, the compiler is going to make use of these numbers right here. All right, the default parameters. So let's run this, and we are supposed to get 5. Yes. So that is what the concept of default argument talks about. All right, so let's go back to our slides and read something. So we have default arguments are passed to parameters automatically if no argument is provided in the function call. All right, so that is what we just did, and I hope you get it. Then the second point says default values are set only once, usually in the function prototype or declaration that's above the main function, right? And we also explained that while we were doing our simple tutorial right here. So let's look at the third point. When an argument is left out of a function call, all argument that come after it must be left out as well. All right, so let's go back to our compiler and let's add some more arguments or parameters in this case. So int c, int d, right? Then let's do plus c plus d, and let's come into our function prototype and let's add some default arguments for these new parameters. So let's do one for c, and int d will be equal to 4. So that works. So let's do the function call. So we call the function and say we want to give a value for our first parameter, right? So let's do 5. And then the next parameter will be for b. The next argument will be for b. So let's do 4 here. And let's say we feel like we want to leave out c. All right. And then give a value for d. This will give an error. All right. So what we just read is saying that if we want to leave out if you want to leave out the argument for any particular parameter, we have to leave the rest out. We don't have to put anything there. All right, so this will give an error. So the right thing to do is to just end it right here. And so there cannot be a case where you want to omit this and then make use of d. All right. Yes, so that's basically it. If you want to use the same default argument here, you have to specify the same value. And if you want something different here, you can say maybe 5. But then you can't take this out and then bring the 5 for the d. Hope you get it. So let's do 1, right? So the lesson right here is don't leave one parameter out when there are other arguments, default arguments after that parameter. All right, so when we run this, we are going to make use of 5 plus 4, then plus 1 and plus 4, which is this is going to give us 9, so 14. So we can run this and we have 14 printed to the screen. Right. So let's go back to our slides. Then the fourth point, the right to left rule. When a function uses a mixture of parameters with and without the default arguments, the parameters with the default arguments must be defined last. So basically, there can be a case where you define this function, you have your default parameters, but then you want to give the default argument to certain parameters, not all of them, right? So in that case, you have to make sure those default parameters will be at the end or the right side of your parameters. So the best thing you can do is maybe do A, B, just like this, and then you can leave the ones with default parameters at the end. All right, but then you can't do it the other way around. Like, let's make this a comment, and so before we make it a comment, you can do this 3 and let's delete this right here. All right, so what we have here is wrong, right? It will give you an error if you try to do this. So if you know you have just a few of your arguments having default parameters, you make sure you bring those ones at the end of your function prototype, right? Yeah, so this will be wrong. So let's comment it out, and we still have this, and then we can make use of this and it will still work. We still expect to see 14. All right, same 14. This is working. So let's uncomment this, which we know it is wrong, and do this, and let's run it and see. All right, so we get an error on line 6 saying default argument missing for parameter 3 and what have you. All right, so if you have default arguments, make sure you take them to the end of your function prototype. Right, so let's take this back to how it was before. Right, and let's move on. We have constant and global values only. Default values must be literal constants like 5 3.14 hello as a string, right? Or global variables that can be accessed anywhere in the code, right? And you cannot use local variables for main as a default parameter, right? So this is very simple to understand. Just make sure whatever you are going to use is accessible in any part of the code, and they have to be literal constants too. All right, so we can play around this. Let's create another function and say full name, right? So let's do void. The function name is going to be full name, and let's have a string. Can do first name, another string to take the middle name, middle name, then a string for the surname, right? And let's have some statements here. So let's just do see out first name, some space, we have the middle name, and some space, and then the surname, and we can do end line, right? So let's have the function prototype at the top here, and with a semicolon, and let's have some default arguments. So with the surname we can do is equal to do, right? And with the middle name, let's go with say gem, right? Then let's just leave this out and let's print this. Let's call our function. So the name of our function is full name, right? Let's just call this, and we want to pass just one argument, which is going to be for the first parameter, right? So we can do Jane, right? And let's end this. All right, so after specifying Jane, we can run this and see how we are going to go about it. So we have this error here. Let's put it in a string, then let's run it again. Are we missing something? So we have this right here. What we specified was just the first argument. Then we have Jane, Doe, right? So this works. We can end the program, and what else can we try? So let's just use another argument. So you can also have create a variable, so m name, and assign it to something. What can we do? Robert. Let's do Robert and end this. So inside here, the second argument, we are going to pass n name. All right. Then the third one, we can pass a string inside here. What can we think of? Let's do David here. Let's do David. All right, and let's run this. So when we run this, we expect to see Jane, the middle name, M name is going to be Robert, and then David. So let's run this. We have an error, and name was not declared in this scope. Oh, should that be a problem? Oh, so we are using N here instead of M. All right, so let's run this again. And there we have it, Jane, Robert, David as our full name, right? So yes, you can play around this default argument, right? And just remember what we went through, and if you want to add default values for some of your parameters, make sure they come to the end of your parameter arrangements, right? Yes, so that will be it for this lesson. We will continue with function overloading right here. So let's dive into function overloading. So we have function overloading. What do we mean when we say function overloading? So function overloading is basically having multiples of functions with the same name. All right, they can have the same name, but what is supposed to be different about them is the number of parameters they are taking or the data type of the parameters. All right, so you can have a function named sum. All right, let's say three functions with the same name as sum. But you can have one adding just two numbers. You can have another sum function adding three numbers. You can have another sum function adding five or seven numbers. All right. So function overloading is basically playing around the same name but different parameters, or it can be the same parameters but different data types for them for the parameters. I hope I'm clear. So let's read what we have here. It says it allows multiple functions to share the same name within the same program as long as their parameter lists are different. All right, so let's just come here and have a new project and write some function and see how this goes. So let's add two numbers, say sum again, and int a and int b. All right, so let's just add them. So return a plus b. All right, then let's do the function prototype up here and have, oh yeah, let's have this. And come on, let's go back. We have, it allows multiple functions to share the same name within the same program as long as their parameter list are different, right? So we have this adding two numbers. We can have the same function, right? But then this time around, we are taking in three parameters, so in C. So let's do another prototype here. And this time around, we add another int C. All right. So this is going to work perfectly when we call the functions. So let's call sum, and let's call sum and pass two values, let's say 1 and a 1. All right, so let's put it in result 1. So let's say int result 1. is equal to this right here. Is this right here? Then let's see out our result one. And again, let's do int result 2 and pass the sum value for our second function, and let's do 1 plus 1 and another one. So we have to change this and add plus c, right? Yes. So this is adding all the parameters we have here. This is also adding the two parameters we have here. So let's copy this and then print that for these two. So second sum function with three parameters, right? With three parameters, and let's print out the value for result 2. It's supposed to result, right? Yes. So when we run this, we expect to see the first one being 2, the second one being 3, without any errors, right? Maybe we can have some, but let's run this. Yes. Oh, we are getting this from our previous work. All right. So let's run this again. Oh, come on. We have to do this. All right. And let's run this again. So we have first sum function with two parameters giving us 2. Second sum function with 3 parameters giving us 3. Right. So that is about function overloading, right? Functions with the same name but different number of parameters or different data types, right? All right, so we can try out something. Let's do a square function, right? And this square function, one is going to square integer numbers, right? And another is going to square double numbers. So let's just create let's say a square. A square, this is going to be our function. Then let's say int num, and let's return the square of this. So return num multiplied by num, right? So this is for our int. We can also do another for double, and keep in mind that with function overloading, the most important thing, the things that have to be different, is the parameters and then the data type. All right, so we are having int here, but we can do double here, double num, and this also works. So the return type is not very important for function overloading, right? So we can do int here, but then just know that when we are returning int, it's going to affect our values inside here, right? So let's do return num multiplied by num, but then this time around it's just a double, right? All right, so let's do our function prototype up there. All right, so if not done for both of them, we can do this here, and then the int. So let's do int here and another int. All right, so this time around, this is taking an integer argument, and this is taking in a double argument. All right. So let's come into our code and print some separator line here, and let's call our int square function. So we can do square 2. All right, so let's just print this out to the screen so we'll see out um, function call for int function, and right here we can end line, and also we can call the double function, right? All right, so these are functions with the same name, but they are having different parameter types, right? Data types for their parameter. This is an integer, this is a double. So let's run this, and we expect to see 4 here, and whatever we are going to have for the second function. So down here we have function call for integer is giving us 4, and the function call for the double function is giving us this right here. All right, so the same function name, but then you have different data types performing their various tasks, right? So this is also possible for function overloading. Yeah, so that's very cool. What else can we try? We've tried this. We have this. Right, so this will be the end of this lesson, and I hope you understood the concept of function overloading. Right, so make sure you like the video, you subscribe to the channel, and share the videos with your friends.